In this video, we are going to be learning about trigonometry. What is trig? How can it be applied to contest problems? So, the basics. So, let's just say, here's a problem. You have this triangle. And you know that this side length is 7. You know that this side length is 8. You know that this side length is 5. And you're trying to determine this angle. How many degrees are in that angle? By the way, the answer is 60 degrees. And we'll learn how to solve that problem later on in the video. So first, you need trig to solve that sort of problem. But first, what is trig? So to answer that question, we start with the unit circle. And center is at the origin, which is 0, 0, and it has a radius of 1. So 1, 1, 1, 1. Yeah. So let's just take, in this video, we're only going to be learning about the trig functions sine, cosine, and tangent. So what is, you've probably seen this before. What is cosine of 60 degrees? That's all about trigonometry. So to find the answer to that question, let's just let this angle be at 0 degrees. This angle is therefore at 90 degrees, so on. So point at 60 degrees is probably going to be about here. And what's cosine of 60 degrees? It's going to be the x-coordinate of this point. And this is 60 degrees, so this is 30 degrees, so it's a 30, 60, 90 right triangle. And so then the x-coordinate is 1/2, so this is 1/2. Okay, so let's try a different one. What about cosine of 120? So it's just the x-coordinate, and this is also 30, 60, 90, so this is minus 1/2, and it's minus 1/2. Okay, that seems pretty easy. Let's try a different one. What about 45 degrees? So, this is just 1, that's root 2 over 2, because it's an isosceles right triangle. So cosine of 45 degrees is root 2 over 2. Okay, so basically, cosine, it's just you plot the angle on the plane and then you find the x-coordinate. Sine is very similar. Sine, instead of the x-coordinate, you find the y-coordinate. For example, if you have the same circle centered at the origin, radius 1, and what about like sine of 30 degrees? So then this is 0 degrees, this is 90 degrees, so then this about here is 30 degrees. So this is 30 degrees. And sine, you guessed it, what is the y-coordinate? So here it's still 30, 60, 90, so that's 1/2. This is 1. Yeah, so sine of 30 is 1/2. What about sine of 150? It's the same thing, it's also 1/2, because the y-coordinates are the same. And sine of 45, so that's just the y-coordinate here, and that's root 2 over 2. So sine of 45 is root 2 over 2. Now, okay, so now you know what sines and cosines are. But what about tan? So tan is basically just tan of an angle x degrees is equal to sine of x degrees divided by cosine of x degrees. So let's see, what about if it's like this angle? So what about here, tan of 45? So again, it's radius 1 and 90 degrees, 0 degrees. This is 45 degrees. What about tan of 45? So we know that the sine is root 2 over 2, and we know the cosine is root 2 over 2, so then the tan is just 1. So tan of 45 degrees is 1. And similarly, tan of 135 degrees is the sine divided by the cosine, so that's root 2 over 2 divided by negative root 2 over 2. So that would just be negative 1. So tan, a good way to remember this is SOHCAHTOA. That means that in a right triangle, x degrees, the sine of x is the opposite divided by the hypotenuse. The cosine of it is the opposite divided by the hypotenuse. And the tangent of it is the opposite divided by the adjacent. Okay, so this basically stands for sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. Okay, so now you know what those sines and cosines and tangents are. Let's try a problem. Okay, so you know that. What about, let's go back, because first, to solve that other problem, you're probably still thinking, how did I get that? So if it's 5, 8, and 7, how did I find that that angle is 60 degrees? So how I found it was using this formula called law of cosines. And there's two formulas that we're going to cover, law of sines and law of cosines. So in law of cosines, basically says in this triangle, it's basically, law of cosines is basically an extension to Pythagorean theorem, but for every single triangle. So basically, it's saying that if we have this triangle with side lengths A, B, and C, then we can find this angle, and this angle, and this angle. So basically, let's just say this angle is x degrees. So then we know law of cosines tells us that the side opposite from x, which is c, so it's c squared, is equal to a squared plus b squared. This is looking like the Pythagorean theorem, but there's more. Minus 2ab cosine c. I mean, that's how the normal formula would go, but instead we defined it to be x, so it's like that instead. It's equal. Okay, so how this looks a lot like a Pythagorean theorem, but there's this term. So let's just see if the Pythagorean theorem works in this case. Let's try a right triangle. Let this be x degrees. X degrees, and we know that x is 90, so we're going to plug that in. This is c, this is a, this is b. So c squared is equal to a squared plus b squared minus 2ab cosine of x. And this is 90. X is 90, so let's plug that in. C squared is equal to a squared plus b squared minus 2ab times cosine of 90 degrees. And cosine of 90 degrees is, if we draw out the unit circle, we'll get that the cosine of 90 degrees would be the x-coordinate of this point at 90 degrees, which is 0. So cosine of 90 degrees, that's 0. And we get c squared is equal to a squared plus b squared. So that's law of cosines. This, right here. Alright, what about law of sines? So law of sines is another formula that relates the side lengths of a triangle with its angles. So let's just say we have a triangle like that. Just say it has sides A, B, and C. Let's just say that the angles are A degrees, B degrees, and C degrees. So basically, what law of sines will say is that A divided by sine of A is equal to B, and this is degrees, like this is the angle. B over sine of B. Obviously, the sine is the angle, not the side length. Yep. Okay, so that's sine. That's law of sines. Okay, so now let's go back to that problem earlier, and let's apply a law of cosines to solve it. So we have this triangle, ABC, and this is 8, this is 5, this is 7. Find angle B. Okay, this looks like it's a job for law of cosines. Let angle B be x degrees. Then we can pretty easily see that using law of sines. 7 squared, which is the number opposite, is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times cosine of x degrees. So then 7 squared is equal to 25 plus 64 minus 80 times cosine of x. So notice here we can find cosine of x, and then we can find x. But that's only hoping that cosine of x is something that we can recognize, like square root of 2 over 2 or something. So we'll get 49 minus 25 is equal to 64 minus 80 cosine of x degrees. So then this is 40 is equal to 80 cosine of x degrees. And how I got 40 was this is 24. Move that over to this other side, so it's 40. Yeah, cosine of x degrees is 1/2. And we know that x is obviously going to be an acute angle. So if we draw the unit circle, it's going to be here. And we know that that's 60 degrees. Because cosine of 60 is 1/2. The other option is at 330. But that's because at 330 it's also going to work. But that's not going to be correct in this. It's not going to work in this triangle. Actually, it's not 330, it's 300. It's going to work. That's not going to fit this triangle because the sum of the angles, we know it must be 180. Okay, so that's a problem involving law of cosines. What about, let's see. So that's how it can be applied. Because that problem did not include sine and cosines in its name. It was just this problem, A, B, and C, and you're trying to find an angle. So how to spot that law of cosines or law of sines can do the trick is that one thing to remember that if you have three things in a triangle except for the three angles, so like if you have one side and two angles, you can immediately find the other two sides using law of sines, and you can find the other angle by just subtracting from 180. And if you have two sides and one angle, you can immediately find the other side using law of cosines, and then you can find the other angles using law of sines. So also if you have three sides, then you can use law of cosines to find all three angles. So basically, if you know three things in a triangle, you can find all the rest, unless the three things are all the angles. Okay, so I've already made some videos about problems involving trig identities, and there's this really important identity that I've already made a video about the proof. It's just sine squared of x degrees plus cosine squared of x degrees is always equal to 1 because of the Pythagorean theorem on the unit circle. Yeah, so that's all. And one thing to note is that when you're using degrees like sine of 60, you don't do sine of 60, you do sine of 60 degrees. Because it's really important because you're referring to degrees, and normally if you don't have the degrees, then people might think that you're referring to radians. And radians are very different from degrees. So here's the conversion. 180 degrees is equal to pi radians. So for example, sine of 2 pi is equal to just sine of 360 degrees, which we can make that down to 0 degrees. And so that's just 0 because the sine is the y-coordinate, and that y-coordinate would be 0. Okay, that's it for this video. See you guys next time.